Projectiles, Horizontal Plane, Type 1 Basics. So this is the question from 1997, where we have a golf ball at rest on a horizontal ground, and it's struck so that it starts to move with a velocity of 3u in the I direction and u in the j direction. We're told that in its flight, the ball rises to a maximum height of 15 metres, and we have to calculate what is the initial velocity u, and we also have to calculate the magnitude and the direction of the velocity which the ball strikes the ground. So we're going to start first of all by drawing a diagram so we can kind of mark in exactly what's going on. So we have our object is struck with an initial velocity of 3u in the I direction, and u in the j direction, and then it's going to be on a horizontal plane. We know that on landing sy will equal 0, so the displacement above the ground will be 0. We're told the maximum height is 15 metres, so in the y direction, and the maximum height occurs when the velocity in the y direction is 0. Okay, so we're going to make out our table based on the information we have. So you're going to do it for me in terms of u, a, v, s and t in both the x and the y direction. So if you're going to pause the video and see, can you fill out the table correctly yourself? Okay, so this time we don't have to go u cos alpha I plus u sine alpha j, because we were actually given our I and our j vectors. We're told 3u in the x direction and u in the y direction. We know that on the horizontal plane there is no acceleration due to gravity in the x direction, and obviously if the particle is projected up into the air, this is in the opposite direction to gravity, and if we're taking u to be positive in the upward direction, then g must be given a negative sign in the downward direction. Remembering that v is equal to u plus at, well then that gives me v in the x direction is equal to u, in this case just 3u, plus at, so 0 times t is 0, and v in the y direction will be u minus g times t. S is equal to ut plus a half at squared. So s in the x direction then will be 3ut, and again a half at squared will be 0, and s in the y direction then will be ut minus a half gt squared, and then t is our time. Okay, so how are we going to find u, the value of the initial velocity? Well, we start with what do we know, and we know that the maximum height occurs when Vy is equal to 0. So what do we know about Vy? Well, we know that Vy is equal to u minus gt. So if I let that equal to 0, I get u minus gt is equal to 0, and therefore gt is equal to u, so t is equal to u over g. So in other words, the time taken to reach the greatest height is u over g. But we have a second information about the maximum height, and that's that at the maximum height, sy is equal to 15 metres. So again, what do we know about sy? Well, we saw that sy was equal to ut minus a half gt squared. So if I sub in for my time of flight, which was u over g for t, and let that equal 15, well, what I'll now be able to do is get u on its own. So I have u squared over g minus u squared, so g over 2, so half g, times u squared over g squared equals 15. And g will go into g squared once, so that leaves me with u squared over g minus u squared over 2g equals 15. So if I multiply everything across there by 2, then I get 2u squared minus u squared all over 2g equals 15. And that gives me u squared is equal to 30g, and therefore u is equal to the square root of 30g. And again, if we go back to the question, it says find the value. So again, often in applied maths, when they're looking for the value, they're looking for the decimal answer. So I'm going to give my answer corrected 2 decimal places. So that's 17.15 meters per second. Okay. So we had 15 marks. So again, for getting our t is equal to u over g, 5. For getting our second equation equal to 15, 5. And for getting our initial velocity, 5. Okay. Now I can also get the time there. So t is equal to u over g. So we have 17.15 divided by g, which gives us a value for the time taken to reach the greatest height to be 1.75 seconds. Okay, so second part of the question then is magnitude and direction of the velocity with which the ball strikes the ground. Okay, so we know then that the time taken to land is going to be twice the time taken to reach the maximum height. So it's going to be twice 1.75. And in other words, it's going to be 3.5 seconds. So therefore, if we're looking for the velocity on landing, it's the magnitude. Okay, so to get the magnitude, I'm going to have to get the velocity in the x direction and in the y direction. So the velocity in the x direction is 3 times u. And u is, of course, 17.15. And therefore, that gives us a velocity of 51.45. Or if we kept it in third form, it would be 21 root 6. And the velocity in the y direction is u minus gt, where again u is 17.15 minus g, and of course the time is 3.5. So that gives us the velocity in the y direction as minus 17.15, or if we kept it in third form, it's minus 7 root 6. So therefore, if we're looking for the velocity vector, well, it's Vx and V in the y direction. So therefore we have our velocity vector is 51.45 in the I direction minus 17.15 in the J direction, and that's meters per second. But of course we're not looking for the velocity vector, we're looking for the magnitude and the direction. So our magnitude, of course, we have to get the square root of a squared plus b squared, so the coefficient of the I and the coefficient of the J vector. So therefore that's the square root of 51.45 squared plus minus 17.15 squared. And that gives us 54.23 meters per second, or again, if we're keeping it in third form, 14 root 15. And then, of course, our direction is tan theta, so our j over our I vector. So our j is 17.15 and our I is 51.45. So that is a third. So tan inverse of a third gives us 18.43 degrees. Okay. So we had 5 for getting our magnitude and our direction, and 5 for getting our velocity vector. So we had 10, 15, 20, 25 in total for our question. So nice little question that.